Hi, do you ever wonder how the semiconductor elements are chosen for the applications ranging from the phone in your hand, the laptop on your table, or the LEDs in your room? I'm here to answer that. Hi, I'm Vikramdeep Singh and I'm a physicist. I'm doing a PhD at Cardiff University, working to understand the light-matter interaction for applications ranging from quantum technologies to biosciences. And I'm not just a physicist, I'm a gamer and a photographer. Understanding how light interacts with matter helps us to do the characterization of optical properties of semiconductor. But the question is, how do we do that? Let's try to understand this in simpler terms. First of all, we need a light source, but not any ordinary light source, but the lasers. We want to look at the optical properties of the matters at very small time scales and very small dimensions, roughly 1,000 times smaller than the human hair. So we need light modulation. Rather than using continuous illumination, we use light in on-off pattern, which is done by the pulsed lasers. Second, we need to look at these samples at low temperatures. At room temperature, the optical properties of semiconductors will be influenced by the temperature, and we cannot observe the intrinsic optical properties. So we need to put our samples in a small chamber which is cooled down to very low temperatures. Physics is when semiconductor materials are illuminated with the light, so the electrons are excited to their excited state. Now they can relax either radiatively by emitting light or non-radiatively. In the former case, light is emitted from the semiconductor material, which is to be detected. Which leads to the third part of our experimental setup, which is the detection of the emitted light from the semiconductor. We use CCD cameras. These cameras are very similar to the cameras in your phone, but much complicated. From this emitted light, we can characterize the optical properties of the semiconductor materials because each semiconductor element will emit at different wavelengths. This whole setup is not only limited to the semiconductors. We can look at other samples as well, such as light harvesting molecules, which are responsible for the photosynthetic process. In complexes, in order to understand the physics behind the process and can implement these understandings for the future applications. That's all from me, and I'll leave you with a question. Where do you see this physics happening in aquatic life? Yes, the jellyfish.